Hello everyone. Everyone's having a good day, or my one viewer is having a good day. Hopefully more people come in the next minute here. Okay. All right, everyone, it's Thursday, it's 4 o'clock, so it's time for you to watch me fall into a ditch using code. That's right, it's another episode of Hacking Hubs. I'm your host, Greg Fodor, and I'm here to show you how all this stuff works. And hopefully we'll make some progress on something fun today. So if you recall from last episode on Tuesday, we were in the middle of setting up a Habitat package for this new Media Soup SFU that I've been working on along with Kevin Lee. And at the time we were just trying to get it building. There were a few fits and starts in getting it all up and running. But good news is that it's now, for the most part, working. So this is the Habitat plan that we had started on Tuesday, and I'm going to just increase the size here for a second. One moment. And I don't remember exactly where we were, but there ended up being quite a few steps past where I was getting stuck. So I can kind of show you that the package built successfully. So this is what you see after a happy Habitat build. And again, I'm running this inside of the Habitat Studio, which is a Docker container that you can use to easily build Habitat packages. So you just get in there using Hab Studio, enter, and then it'll pop me right back in to my Habitat Studio. And so if I ran build right now, it would rebuild it, but you take my word for it that it will work. It's just a little bit long because it has to compile a bunch of C++ code. This is the code from the Media Soup SFU. And so there's a few things that came up I'd like to talk about briefly. And then I'll also go into a little bit of the configuration work I did. That was, I think, where we left things off. So actually, let's start there. So if you remember, the key thing that you need to include in addition to the plan for a Habitat package is, I'm going to change this track. This track is really not fun. Okay, to listen to while you're trying to think. So if you recall, there are two parts to the Habitat package that we basically were focused on. The first was the plan, which I just showed, and this is the script that runs, it's bash, that Habitat knows how to interpret for defining the metadata, and then also the various functions you can override for the packaging process. So I'll jump back to this in a second. Now, the other element we talked a lot about was the configuration process for a Habitat package. And I mentioned quite a bit how Habitat will manage configuration for you and how your role as the package author is to abstract away a lot of the incidental details when it comes to how a package or the underlying process a package runs is configured. So again, sometimes you may have to use environment variables to run a process. You might be using configuration files. Habitat's packaging system and the various bits that you can include in a package allow you as an author to encapsulate all of that weird, quirky stuff into a unified configuration interface that the operator can then use to configure the package and the service that the package contains without having to understand how it all fits together under the hood. So if you recall from last time, we dug in a little bit to how this SFU is configured under the hood. And so it actually comes with a stock configuration file that is just a JavaScript file that is loaded in the index.js, which is just the startup routine for the server. And you can see it's loaded right here. And the only goal of this file is to export various configuration bits. I'm going to go ahead and increase this a little bit more just because it looked like it's a little hard to read on the stream. And so this configuration file isn't necessarily a Media Soup SFU configuration. It's the configuration for this particular SFU, which is built on top of the Media Soup server API. This is included in MediaSoup's demo project, and we forked that SFU implementation into a service called Dialog, and that's what Kevin and myself have been working on, is kind of getting that all together. And so this configuration file, one could say, is the Dialog configuration file now. We haven't really significantly changed it, but it's effectively the configuration file that is going to be used for setting things up. Now, as you remember, the two ways to have Habitat kind of manipulate the configuration that it sees from the operator is it can generate files on disk based on the template you provide in the package, or it can actually it can actually insert those into the various hook scripts that you write, which are also themselves templates. And so at the time I was going over this last time, I was considering whether or not to keep this configuration file as is, or turn it into a template in Habitat. So the reason for that difference is just that, as you can see, this JavaScript file is loaded directly by index.js, and it's kind of part of the application JavaScript code. And so it's not, it's a little bit unclear that how to actually fit it into a dynamic configuration file that may get dropped. So that was a little incidental thing, not a big one, but just something that kind of was in my mind. And the other element to it is you can see it already includes the use of environment variables to insert certain values. And the environment variables that it exposes happen to be the ones that really are the salient ones for configuring this for us. And so after thinking on it a bit more, I did decide for now to just keep the file as is, not use a template in Habitat, and then just use the environment variables as the core configuration. Hey, welcome to the stream. Use the environment variables as the core configuration mechanic that we're going to automate within the Habitat package. Just makes it so this file really won't have any kind of custom changes by us. I won't have to move it into a template. It just kind of it'll result in a slightly less surface area in the artifacts, and also less likelihood that we'll have any kind of strangeness that comes up if we do continue to merge patches in from the upstream, because we would have to then go on and to incorporate those into our template in our package. Whereas by using the environment variables, that seems a little bit less likely to have any future-proofing risk, since it's already kind of by the author seemingly the de facto way to configure the service. So he or she is less likely to come back and adjust how those are used. If anything, there probably will be more environment variables that can be tweaked, not changes to the existing ones, if I had to guess. So that led me to just decide to use the environment variables for the configuration, and so that's what I ended up doing. So let's just start at the bottom here. This is the more simple part of this. So the environment variables involved here to run this SFU are the domain name, the path to the private and public elements of the SSL certificate for the WebSocket server, the IP address that we're going to listen on, and the port we're going to listen on. Now, these are the configurations that came out of the box in the upstream configuration file. And so if I go to the listen IP reference in the config file, you'll see the bit that we were discussing last time. Oops, let me just find it here. Sorry, one moment. I just need to remember this. That's strange. I'll have to think for a second here. Did I not update this properly? So if you recall, there was some additional stuff I needed to do to enable turn. I'm not seeing those changes though, so I'm kind of wondering what may be going on here. Let me just take a look. See if it's in my Git history. Let me take a look at this commit. Perhaps I didn't commit those. No, it's easy enough for me to remember, but let's see. Okay. Yes, oddly enough, it looks to me like I didn't commit those. So I'm going to go ahead and do that now. It should be relatively straightforward. Perhaps it's, oh, you know what? Perhaps I never actually brought it into Git. So I'm going to go ahead and just SSH into our server that I've been testing on. And I think that that might be actually where the existing configuration, thanks Kevin, the existing configuration stuff I was messing around with. I think I was just doing it live on the server and I never brought it back into Git. So I'm going to go ahead and do that first. So, and that's actually a necessary thing to do before we attempt to deploy this, obviously. So I should definitely do that first. So if I go into in here, let me just now verify my assumption. So yep. So this was the slight tweak I made to the configuration. Basically now, instead of having a single binding for the server, I came up with this clever trick, if I do say so myself, to have two bindings, one bound to 0.0.0.0, which has the public IP address announced, and then a similar binding that's strictly binding to the private IP address, therefore causing the public and private IPs to get advertised in the candidate list, letting us both then support turn and non-turn connections. And so I'm going to go ahead now and just pull that stuff in to this the Git repository. It's a fairly minor change, but critical, because otherwise we would not have support for turn. And so the only real difference is first we have this additional binding, and then it's going to have that as the 0.0 binding, and then the announced IP comes in here. So announced IP, and then it will be media soup announced IP, and that I believe should do the job. And then my linter will pick it up. I'm gonna go ahead and add it. And then while we're doing this, I'm gonna go ahead now and kick off the build of the package, because we need this to get into the package. And I'll continue discussing the run hook changes I mentioned. So add necessary binding to enable advertisement of SDP candidate for public IP to enable turn and non-turn. As I've mentioned before, my commit messages are way better when I'm streaming over the internet. So that's a tip to anyone out there that has a tendency to write very short commit messages, such as whip or fix or to do, such as those things. You can avoid them by streaming your commit messages over the internet for other people to watch. So hot tip on that one. So anyhow, okay, so that all looks good. Let me push it to master. And now I'm going to start a build. Nothing really crazy here. It's going to just go ahead and do an npm CI. I'll go and jump to the plan in a second so you can see the steps. There's a few little magic steps that I like to talk about that are kind of interesting if you're someone who's interested in Habitat's internals, but I'll talk about those shortly. So the okay, so where was I? So the config file's checked in, and the package is building, and so I'm going to go back to my run hook now and review it a bit more now. Let's see. I suspect that my disk is full again. I know everyone's waiting with bated breath for me to get a better computer, but unfortunately you're going to have to suffer through me deleting files and all of this jazz. Oh man, you're going to see this explode in a very terrible way now. Oh no, it's because I didn't log out from my studio. There's actually this really fun issue where if I accidentally remove these files that encapsulate all of the namespacing for the Docker container, that it explodes in quite a fantastic way. But not today, unfortunately, for everyone who likes laughing at me when I faceplant on the stream. And so anyhow, so okay, now I should have some disk space. I'm going to remove these additional result part files, which also have been taking up some room. These are just builds from my previous attempts, and get back in my studio while that's going, and now I'll jump back to my my editor. Okay, so back to the run hook. Okay, so if you remember in that config file, it pulls in a few environment variables. The listen IP is the one that is directly going to be bound to with no announced IP. And so that, in this case, will be our private IP address. And so that's that one. And then our listen port is here. And then we run the service after exporting these. So where do the values come from? Well, the domain name on Hubs Cloud and hubs.mozilla.com can be easily gotten by running the hostname command. So I just do that. Now, I guess I'll go off a sidetrack here. This will be a little bit confusing probably, but I'll explain why. So a few of these configurations are going to be a little bit odd, and the reason for that is right now when we are deploying our SFU to Hubs Cloud and hubs.mozilla.com, obviously we're deploying Janus, which is the other SFU that we've used up until now. And so one of the unfortunate elements of how we did Hubs Cloud is that there's not a way for us to deploy new services, specifically new Habitat packages, to existing stacks that have been created by others. But in this case, this SFU is interesting enough to us that if we decide to go forward with it, it certainly would be ideal if we could deploy it to the existing stacks. And so therefore, we need to come up with a kludge. And so the method that we're considering is actually effectively deprecating the Janus SFU. Again, this is all subjective to if we go subject to if we go forward with this. But let's say we decided to do that. We would deprecate the existing Janus SFU, and also from that point forward, all future packages that we submit to our depots that are that seemingly are Janus would instead contain this new SFU. So we would have to update the description of that package as such so people aren't confused and think that it does contain Janus. But nonetheless, it would contain this new SFU. Now, really the only core aspect to that package is it's the SFU you would want to deploy. Hey, NPV. Would be, that this is the SFU you deploy to run hubs, right? And that's kind of the real core point of that package. So it was a little bit regrettable that we didn't name it something else, because in fact, while it is Janus, it's a very specific flavor of Janus in that we have certain configurations we expose. We also include as part of it our Mozilla created SFU plugin. And so really, I kind of regret not calling it something like Dialog, a specific internal code name for the SFU that you should be deploying with hubs. And so in that case, really, if we were to swap out Janus for this new SFU, there would be really no strangeness to it. It would just be an evolution of the underlying approach we took to SFUs, but it would still effectively be a new version of Dialog from a package perspective. It just under the hood would be using completely different software. So that's one reasonable way to think about it, but since we didn't name it that way, it's going to be a little bit odd to find this Media Soup API in a package that says that it's Janus. But I think all things considered, that trade-off seems to make sense because the ability for people to migrate to a new stack is quite high compared to if we just deploy this. And if the upside is large enough, there gets to be a point where you decide that makes more sense. And so far things are looking encouraging enough. I think there's a good chance we might just do that. So all of that to be said, the reason that some of these configurations are weird is because we effectively need to write 2 run hooks for this package. One of them is and the only one I've written so far is this one, which is the one that is designed such that it's based on if you're uploading it in lieu of Janus, right? So basically the design constraint there is we want the run hook to only really use variables in the configuration that are the same ones that we use with Janus. Now it turns out most of the values we need, if we were to kind of silently replace Janus with this SFU, most of the variables we need in the configuration are already there. However, they're a little bit counterintuitive in where they're coming from, particularly the listen IP, which is in the AWS deployment and in the DigitalOcean deployment is the, or actually the DigitalOcean one I have to think about a bit more. So I'll talk about the AWS one for now, just on that side. So the listen IP is just the private IP address. If you remember, we want to bind just to the private IP address. Now in the currently deployed Janus configuration, we do not have the private IP address kind of explicitly configured, but we do incidentally configure it for an internal binding that Janus has on its private IP address for administrative API use. And so we're going to kind of hijack that variable, which we know to contain the private IP address, and use it here so that the configuration can be simplified and we won't have to say look it up because we know it should exist in the configuration of all the existing stacks. So that's why this kludge variable is used here. This transports HTTP admin IP. We happen to know that it's the private IP address, and this is not that scary, and the other thing I'm about to explain is not too scary because we can be sure that all future stacks will not be using this methodology. We certainly will go on to create a proper habitat package and run hook for Dialog itself, which will not be kind of secretly slotted into the Janus one. And in that scenario, we can properly configure it in the way we would want to. We can name all the variables how we would like and all of that. I haven't done that work yet, but basically right now, this is what we're working on, is getting this one that we can slip into the Janus channel distribution. And so that leads me to this other block of code right here, which the other element we need is the public IP address. And so that one is a little bit more of a reach because it turns out we don't actually configure Janus with the public IP address on a good number of Hubs Cloud stacks. We in the very early days, the first version of Hubs Cloud did, but subsequent releases, which added turn. Oh, it's an interesting question. Could we have the Janus package install that package? I hadn't thought of that before. I'm not going to riff on it live because I don't want to say anything too dumb, but certainly that's something we can maybe talk about afterwards, Dom. And so anyway, back to the public IP address. So that one, it turns out, is not available in all stacks in the configuration. The very early stacks do have it because we were configuring the public IP address in that explicit advertised IP. But then with the introduction of turn, if you recall, I added stun compatibility, I added the use of stun to derive the public IP. So it was no longer necessary to drop the public IP address into the configuration state on the server. And so there's a whole sidetrack I could get into here, but I won't. But nonetheless, the point is that this run hook for these packages that are getting dropped in lieu of Janus are going to need to dynamically derive the public IP address because it won't be available to them in the configuration. And this is one kind of configuration value that we will not be able to introduce dynamically later due to some incidental details I won't get into now. But anyhow, the mechanic to get the public IP address varies. So on AWS, there's an internal HTTP API you can use to fetch it, and that's what we do here. And then similarly, there's a very close API you can use on DigitalOcean to do so. In fact, these are so close, I do wonder like where this comes from. I don't actually know. I think that there's probably some unifying specification for this stuff. Perhaps it's the Cloud Init specification, if I had to guess, but I don't know offhand. And then just as a sanity check, it does fall back to using just local Unix tools to get the binding of the first Ethernet card. But in practice, this package is only going to be deployed to existing Hubs Cloud stacks and DigitalOcean stacks that are Hubs Cloud clouds on AWS and DigitalOcean. So this code should be completely dark and never get run. But just for the sake of completeness, I wrote it because we already had it, and it does a good job of getting the public IP address in the cases where these curls do fail for some incidental reason. And so that's what this is doing, and that's just adding that last configuration. And so that's our run hook. That seems to do the job, gets the environment variables all in the right place, and then causes the service to come up properly. And so, oh, I forgot to kick off the build. Let me do that now, and then I'll talk about the plan. So the plan is fairly straightforward, except for kind of two little bits that I thought I'd call out that might be interesting to folks. So the dependencies we already kind of went over. Those are just the dependencies that build and create time. The installation step, I did do a little bit of tweaking here. I only want to copy certain folders and pack them into the output, and you just do that by copying whatever you want to get created into this package prefix directory, which is just a little bash variable that's present for you when you're doing the build. There's actually a variety of bash macros that are available that you can find in the habitat documentation. Package prefix is a common one because this is the one that is effectively the path to what's going to get sucked into the archive. So anything you want to drop in there is going to be part of what gets installed on the machines. And so it's very common to just copy everything into there at the very end. And then I just clean up some node module stuff. So the magic bits I'll talk about in depth are these two steps, so I'll skip over those for now. So this is the build step. This is what actually the goal by the end of this is to have compiled, generated whatever your thing is responsible for doing to generate the artifacts. It should do it in this step. So first we npm install media soup. In this case, it's particularly installing that because I remove it at the end. I don't actually recall if that's strictly necessary. I'll have to think about that, but we do install it at the beginning just to fill it in if it's missing from the last run. And then the magic things happen I'm going to talk about. Then I go into the nodes modules directory, and I noticed when I first started creating this artifact, it was quite large. It was almost like 200 megabytes, and I was kind of scratching my head what the heck that could be. I certainly knew that media soup was sizable. It would have C++ binaries and so on, and a bunch of other related libraries that I already know we need, like USCP or USCP for the data channels, the libsRTP for the secure RTP connection management, and all that. But I was surprised at just how big it was. And so when I dug into it, most of the stuff was just incidental artifacts from the build process. So there's a bunch of dependency stuff that's sitting in there that can be removed. There's a bunch of output target stuff that gets removed, like the binaries and all that get copied multiple times, even though you only really need one copy of them that's used when the surface view comes up. And then a bunch of C build tools apparently get pulled in as well when you do the npm install. I guess it must build using Clang and not from the compiler that's installed in the environment. So, and then I also removed like dev tools that turned out to be a few megs each, the linter and the prettier. Those aren't needed obviously in production. So that just cleans things up. So the archive now is only about 40 megs when you clean all of those up with no loss of actual capability, because you still get all the binaries and libraries that are actually needed to run things. Okay, so then the question is, what is all this? Okay, so if you go and look at Habitat's core plans, it took me quite a while to really realize this was what was going on. But one of the things that the build packager does is, as you may recall, the way Habitat sandboxes all of the various processes that run is just through like clever manipulation of the environment primarily. There are other ways, which I will talk about next actually. But it sets up environment variables so that the dynamic linker has all of that, and it's going to have a huge list of paths that point directly to the library paths for all of the dependent Habitat libraries that have been installed on the machine. So at the dynamic link time, it's not going to be looking in some general library path that is typical. It'll be going directly to a specific folder for each dependency and linking in those. And so part of the environment that has to be managed properly is the build environment. And so the build environment needs, similarly, those kinds of paths to be defined, so any compile time linking that may need to occur actually also properly links to those libraries, and also burns in those links to various things that may come about from the build process. And so if you look at the log of the build step, which I think I can pull up here, of this current build, you'll see after it pulls the dependencies down from the depot, it actually tells you what it's going to set the environment to in the shell context that it's going to run those build commands in. And you can see it actually includes all of these different flags to the linker, the preprocessor, the compiler for linking in dynamic libraries, and also include files for the compilation process. And so the linker one is the one that's material really in this case. Or sorry, I should correct that. The thing I'm going to talk about right now is actually the compiler flags. So the compiler flags it includes, you may notice, are the C flags, CXX flags, and CPP flag environment variables. And this is a very common convention in C compilers, like GCC and CMake, to use those flags in lieu of any flags that may be generated by the configure step. Now that's quite something, because it does mean that configure, for example, if it's decided to generate a makefile that has optimizations turned on in this case, the Habitat builder environment blows all of that away, which was shocking for me to realize. However, it's a known issue, and it's something that the Habitat folks are working on, but it's just been backlogged because they've been in the process of kind of continuing the what I'd imagine to be a very unfun task of maintaining a package repository of a countless number of Unix libraries and tools. So their backlog is, I'm sure, swamped by just maintaining those plans. And so cross-cutting concerns like this one, where compiler optimizations often can be not enabled because of this environment blowing them away, has not been prioritized over the general maintenance tasks. But hopefully that'll be fixed soon. But nonetheless, once I identified this potential problem, I kind of was like, wow, that means a lot of the binaries we're running in production may have been compiled without optimizer flags turned on, which to say the least was concerning. And so I went ahead and I looked through all the things we were actually building and using dependencies that were built through the normal Habitat build chain. And sometimes things were fine because the actual build process was clever enough to avoid the use of these environment variables as the exclusive way to introduce the compiler flag. So in many cases, for example, libc and OpenSSL and a variety of other things didn't care that the optimizer flags were excluded from the environment variables. But there were many that were surprisingly important that did. And so, for example, glibc, zlib, some of these core Unix libraries that are used by like lots of software were being compiled and are actually still sitting on the Habitat depot with compiler optimizations disabled, which, you know, depending on what you're doing may not matter, but in our case, I was nervous about it. So ultimately, what that led me to do were kind of two things. First, figuring out a proper workaround. And so the proper workaround in this case is a very simple little idiom I've developed where I just go ahead and I re-export all the environment variables for compiler flags and then just tack on the two flags that are typical, which is the optimizer flags. I use O2 just to be a little bit conservative because O3 is a little bit less likely to have complete compatibility, and then the G adds the debugger symbols. I think it adds the debugger symbols. And this just sets things up, so now at the very least, the compiler optimizations will be enabled. There certainly could be a lot of other flags that I may not be privy to that the configure step may be adding that are dropped, but the compiler optimizations seemed quite important to get in there, so that's why that's set the way it is. And so, you know, all the testing I've been doing with MediaSoup so far has been with the binary as built through the normal build process. And so it'll be interesting to see if the performance holds up once we deploy it through through this Habitat package, because certainly it could be the case that perhaps there are some sophisticated compiler optimizations we won't pick up with O2 that will no longer be there. So I fully expect to do additional load testing because of this potential problem once it's live in our test development stack, or at least on a server that's deployed it with a package like this. So that's the long story on this. And I'm just mentioning it because anybody that is going to be trying to develop these packages certainly should do this. Yes, we can go ahead and we can look at the build step. In fact, maybe we should just do that on the stream. So it's going to hide it. We have to basically look at the process as it runs, or we could go back and trace through configure as well, like you mentioned, Dom, to just see what it's actually going to do. I did confirm, out of my morbid curiosity, if I didn't do this, if the optimizer was disabled, and sadly enough it was, so this is important to do in this case. I didn't go so far as to dig into all of the build step tools that are used for MediaSoup, but it does seem to fall into the category of the ones that burned other packages as well. So anyhow, that's necessary and potentially very important because the SFU is a highly performance sensitive thing. And a lot of the reason we've been doing this work is because of the performance benefits that seem to be there. So that's a big deal. And so then the next thing I'll talk about is this patch elf run here. And the fact that I needed to do this is a bit of a mystery to me, but it does serve as a place where I can explain a little bit more about some of the things that Habitat does. And so, as I mentioned, the key way that Habitat isolates and sandboxes these things and ensures they're going to have reproducibility, namely that they're going to always bind to the exact library that was available at build time, is through the environment and the dynamic linker environment that it sets up. However, in addition to the environment, another method for which linking occurs, and I'm not going to presume to be a Unix expert enough to really articulate this very clearly, but the ELF binaries that you create also have baked into them what is called the R path, and this is used also for dynamic linking. Like I said, I'm not an expert enough off the top of my head to know the difference between the linker paths that warrant the use of the LD library path, which is typical, versus the R path, which is like a build time path that gets burned into the binary. And so if I hop on the server, we can actually take a peek at this. So there's a Unix tool called readelf, and that doesn't have anything to do with, I'm going to make a bad joke, I'm not going to do it, it's too embarrassing. But what it does is it opens up the ELF binary, which ELF, by the way, is the most common, I would guess, executable format for Linux. And so this tool, readelf, will give you a dump of the ELF, I believe it's the headers of the ELF executable, but I could be wrong. I don't really know the structure of the format off the top of my head. I've gone down the rabbit hole before, but I don't have it in cache at the moment. but nonetheless, it does show you the library run path, which is typically called the R path, which you might see flying by sometimes when you're building software. But in this case, you can see it's part of the alpha executable, and in this case, it is pointing to a absolute path to a Habitat package. And so Habitat, as part of its build process, I believe will sometimes do this. It will automatically do this binary manipulation. There's a large, I can even see if I can find it live on the stream. There is a entire blog post about how this works. Let's see. Yeah, so there's this Habitat application portability and understanding dynamic linking of ELF binaries. So I had read this at one point, so I had a much more clear understanding of all of this, but it's kind of escaped me at the moment. But this is something that I'll also paste it in the stream for posterity. If you're really, really interested in how Unix dynamic linking works, Habitat is kind of does force you to have a bit of a crash course, given that it really relies upon all of these various pieces to get the linking working properly. So that's something I had to do explicitly here. For whatever reason, Habitat wasn't able to fish out and recognize this binary that does get built during npm install. And so what I had noticed was I would deploy this package and the dynamic linker would fail to link with the standard C++, the C++ standard library, which is libc++.co. And so the first problem obviously was I didn't know I needed that, which in retrospect is obvious, but I didn't know until I saw the error. And then I had to throw in this dependency, but it continued to fail. So that told me it was a linker problem. And I would have actually expected it to not fail because of that, because typically the linker will work from the load path, or in this case, the LD run path, to pick it up. But that wasn't working, and so I realized this was one of those cases where I needed to patch the ELF binary to do that. And so that's what this does here, is it patches it to include the lib directory. Perhaps that might even be why the environment was working. Perhaps the lib directory was not the one the Habitat was injected, just speculating on that one. And then just patch the binary that was built. And so finally, after I did that, the SFU started to come up and not have any problems linking to the standard library. You can see this build is still going, so it actually has to build quite a bit of stuff. I think it's building all the dependencies as well, so a very large scope of things if that's the case. And so ultimately this is the build step. It gets everything in the right place. The binary from MediaSoup is built. It's properly going to link, and then it takes all that, throws it into the archive, and that's it. So really not a lot of code, 29 lines here, 40 lines there. This code will have to be tweaked for the MediaSoup specific one. In fact, it'll get shorter because we don't have to do a lot of this hacky stuff here. But that's really all that was needed to turn this from just a dumb binary installable package to something that can be completely automated in production with configuration, supervision, automatic restarting. All that stuff comes along for the ride now because we did a little bit of work to templatize the run hook and properly set things up so that it will run in this Habitat sandbox environment through both the linker and actually making sure the binary is built with optimizations turned on. So that kind of concludes the end-to-end crash course in Habitat package creation, which started last week. And now, today we'll transition to actually operating a service through Habitat on your machine. So fortunately, it looks like this is now finally finishing. And so it's just going to tar it up. And again, hopefully it'll land about 40 megabytes, if I remember right. And then what I'll do is I'll actually set it up on this, the machine I've been using. And in fact, you'll be the first to see a full integration test of this with the Habitat package. So I can't promise we won't hit more problems because this is about as far as I've gotten. But that's where we'll be now. And then once that works, we'll see how far I can get with going a bit farther to figuring out if we can deploy this to production, or not in production, but to the dev infrastructure. I'll speak a little bit more. I imagine that we won't get that far, but I will talk a little bit about some of the additional bits of work that need to occur before we can deploy it there. Because I did realize there's one or two things that I think will block us from doing that today. So while this is finalizing the heart file, which again is the artifact we should expect to get, a heart file containing all that stuff, I can show a little bit about how things are organized on the server itself. So if you recall, we're using Biome, not Habitat, on these servers, which is the open source community distribution of Habitat. And so, So you can see there's the supervisor process I mentioned is running at all times. And this is the only thing on the machine that's managed by some other thing than Habitat for supervision, because obviously it is Habitat. I'm going to just call it Habitat because even though it's Biome, it's Chef Habitat under the hood, but open source and unbranded. So Biome is managed by systemd, the actual service. I apologize, I keep going back and forth. You just have to do the translation in your head. So, it's registered as a systemd service. We set it up in the AMI. I'm not going to stop it now, but you can see it's running. A couple noteworthy things is it's basically binding itself to various internal IP addresses. There's a couple RPC services that it runs, a couple HTTP services it runs, and it sits there and it's supervising all the services that the machine is responsible for. And the other thing about it that I didn't mention yet is that Habitat operates as a distributed system. And so when you're running Habitat's supervisor, it is set up so that it actually will gossip and connect to all the other, or direct or indirectly connect to all the other supervisors in your infrastructure. And so it's very important that you ensure proper firewall rules and connectivity over the internal communication paths needed for Habitat to properly interconnect in your cluster. And so it'll generally connect to a number of several peers. It's a pretty classical distributed system, similar to, I would say, Console maybe, or Zookeeper in that sense. And so when you're looking at Habitat, you should look at it in part through the lens of distributed systems. One of the key reasons it is a distributed system is because of the configuration management problem. And so the configuration in this case is something that you upload. So say we want to change the port of an HTTP server, right? If you remember, the configuration mechanics are defined by the package, but we still have to have the value of the port, right? And so as I mentioned, the value of the port is in the state in memory of the supervisor. And we can say to the supervisor, go from port 80 to port 44, 483, and it goes through the kind of mindless process of generating all the configuration from that new value based on the package contents, and then bouncing the service accordingly. But then, of course, you might be running that server on that service on other servers as well. And that's the key reason that Habitat should be thought of as a distributed system. When you actually make the change to the value of the port, the Habitat supervisor doesn't just take care of itself. It will also gossip that configuration state to all of the other supervisors in the ring. First by talking to its direct peers, and then those peers will go on to gossip that information to everyone else, eventually getting to every node in the connected ring. And subsequently, those nodes too will go through the same process of applying the configuration and bouncing the service. So very, very quickly, you will see your service all simultaneously restart across your entire infrastructure using the new port. Now, there's a lot of functionality that can be unpacked. For example, Habitat does support rolling deploys. It supports having leader election such that a server will be able to orchestrate things by being elected the leader. I won't get into a lot of these things. Needless to say, there's a variety of distributed system concerns that come up when running this in production. We do not utilize a lot of them ourselves because our clusters tend to be small, and various bits like network partitions and things like that are ones we haven't really spent a whole lot of time worrying about. But nonetheless, we do set things up in a relatively sane way, and we do ensure that the ring has interconnectivity. So for the most part, all of the functionality around Habitat as a distributed system is available to us to evolve into supporting over time. But right now, we're not really using all of the bells and whistles per se, but we are utilizing it for doing this configuration sync. And so if you're a Hubs Cloud operator, when you go into your admin console and when you make a change to the configuration that may affect the running services, some category of those changes will do what I just mentioned. They will force a value to change in the Habitat supervisor ring, but that originates by just changing the value in a specific server. Basically, it ends up being a random app server that you happen to be connecting to when you post your new values to the administrative console. But the side effect of that is immense. It will actually go on to gossip that change to the other Habitat supervisors in your entire AWS infrastructure and in that stack specifically. It won't obviously communicate with other stacks, but within that VPC, it will end up causing those services to bounce. And that's part of the reasons why Hubs Cloud was so exciting to us, is because it gave us, or the use of Habitat in Hubs Cloud was so exciting to us because it effectively made it so we could do a lot of these, usually fairly difficult distributed systems things using this all-in-one solution. So once we got things set up properly, you are operating it as a distributed system and it becomes horizontally scalable, both in being able to support more usage, but also being able to manage it without it being very different. So that's a really nice characteristic of this as well that I hadn't mentioned until now. So when we're running the supervisor on the server, obviously the process is running, but we don't really have a good sense of what's going on with it right now. And so the way it works is that the Biome supervisor actually has a very simple internal protocol that it speaks with a command line tool. In our case, this is bio. I'm going to go to my root just so that you can read this. And so if I run bio, this is the same as the hab command if you're using Habitat. And there's a lot of stuff you can do here. Some of them involve the supervisor, some of them don't. The ones that involve the supervisor, the root supervisor concern is bio sup. So you can run that and see what you can do. Very commonly, I'll instruct people in our Discord to run bio sup status, which will give you a very good bird's eye view of what services the supervisor has been delegated to actually have as registered, and then also of those, which ones it's attempting to run and which ones are actually successfully running. And so each of those three concerns are distinct. So the supervisor may have a service registered, but it has not been asked to run it. And that's basically because the package is installed, the service group is set up, but now we decided we don't want it up at the moment. Or it can be desired to be up, but not working, in which case it would be desired up, but down. And that can happen if, say, the service is not able to start for some problem. And then, of course, the hopeful state is that anything you want to be up will be up. And that's, as you can see here, the case for about four of the services that this machine is running. Now, our Hubs Cloud infrastructure is set up so that there's two kinds of servers. And the key differentiation between the two is which services the Habitat supervisor on those machines is designated to have active and running. So if you're just running one server or just app servers, those are actually kind of distinct from if you were running app and streaming servers. So app servers that are running on their own, under the hood, actually are a distinct type. Specifically, those servers will run all the services you would need to operate Hubs Cloud. So this whole list here would all be up and hopefully up. Now, if you're running streaming servers alongside your app servers, the role of the app servers change as well. And so they only will run everything except those needed for streaming services. And then the streaming services, which is the kind of server we're on right now, will be responsible for running the necessary things for providing WebRTC communication. And so you can see that's specifically the Janus Gateway service, the CertBot, which is used for SSL certificate management, and that's needed on all the machines. PG Bouncer, which, as I mentioned in a previous stream, is used to communicate with the database and ensure the database is paused if it's not being used. And then Coturn, which is our turn server now, that will allow us to connect on a singular port and speak over turn to the underlying Janus service in this case. So that's why those four services are up here, and this biosup status command will give you that. Now, there's a number of other commands I'll get into, but that kind of gives you the ability to diagnose at a very high level what may be going on. And in conjunction with journal control-f, which will tail the global log, you'll get to see if there's anything broken, if one of the services is intended to be up but is actually not. Okay, so we can see our build finally did finish. And I'm going to go ahead and show you, it ends up getting spit out in the results folder. And as I had hoped, it's 40 megabytes or so. And so I'm going to just copy that up to my box. I copy it up to a really simple file name just for the sake of less typing. It's just d.heart when I upload it. Doesn't matter what the name is because the metadata is all baked into it. It's not important what the file name happens to be. And so I'm going to just upload it. I've got my two-factor SSH. And so there are two kind of relevant commands now. So there's the package commands and the service commands. So I run bio, you can see there's package, PKG, which is used for managing packages. And packages are just kind of, files sitting on disk. They're not doing anything. They basically are just the bits that we included in our package and other packages that package may need in the form of dependencies. But they're not really an active thing. They're just either present or not present, and they have versions, as you might imagine, but you install them and they just sit there. It's kind of like your typical apt install workflow for managing packages when it comes to Habitat, except that they will pull in, well, similarly, it'll pull in dependencies as well. Now, the more active and Habitat or Biome specific concept, though, is service management. Because again, this is not just installing stuff, but it's also trying to run it. And the supervisor is responsible for that. And so the sub command was used to manage and view the state of the supervisor, whereas the SVC subcommand is used to manage specific services that the supervisor is responsible for running. So we're going to touch on both. So once this heart file is up, we'll first just install it. Now, that's not really typically how you would do things because, as I mentioned, there's usually a depot involved, a package repository. But since I'm kind of manually testing this, I'm not going to be uploading things to the depot just to shortcut that step. I'm going to just be copying heart files up directly and then installing them manually. And then once it's installed, I'll show you how to manage the service that it's running. In fact, I'll start that now since it's still uploading. So if I run bioservice, you can see there's a number of commands here. You can start and stop services. Those are assuming that you've already registered them. In fact, the term I should use is load and unload. And so a service is, when a service is loaded, that's kind of a larger thing to do where it will then pull in the latest package that it needs to have, or sorry, I should say, it will install the package it needs if it doesn't have a package to use already. So it will not upgrade packages if you do a service load unless it discovers that it needs to upgrade a package due to other switches you may have passed. So this will let me speak a little bit about the service lifecycle for Bio. So service load has a lot of switches, and the reason for that is this really defines a lot about how Habitat operates the running service. And typically, you'll only load a service once on a machine. It's kind of setting it up for its entire life as the machine exists. You may stop it, which is the other thing I mentioned that is kind of separate from loading and unloading. But starting and stopping it is kind of an incidental temporary thing, whereas loading it is kind of laying down the foundation for a long life of that service being managed by Habitat on that machine. Now, in the case of this quick diagnostic, I will be repeatedly unloading and loading things to kind of force it to pick up new packages. But typically, the service will only be loaded once in production. And in fact, we'd actually do that in the AMI build for our Hubs Cloud instances. We don't even do it in the boot. We service load everything in the AMI and then burn the AMI in. And then we just simply start and stop services that are already loaded in the boot script. So that way, the load step actually never happens on the live machine. It happened before the machine even existed. Now, you might wonder why load is such a big deal. Well, load sets down and the foundation for upgrades. So when you load a service, I mean, this is one reason, there's several, but one of the most important ones is that it lays down the foundation for having graceful upgrades. And so when you load a service, if you don't specify anything, it'll just run the bits you have. And if you go ahead and manually install new ones, it'll pick those up and restart and run those. But often you want to do something a little bit more sophisticated. You actually want the service to run, but if the author of the package deploys a new release, you want the service to grab the new version and gracefully migrate the server to the new version. And that's what we use to upgrade your Hubs Cloud instances automatically. And so when you reload the service, you're going to tell Habitat, hey, don't just load this service, but start listening for new versions of this package. And if you see one, grab it and restart it. So that way it'll be upgraded. And so this is also a very, very useful piece of functionality, as you might imagine, and made it so that it was very, very easy for us to support the ability for us to improve the software over time for folks running these servers. It's not without risk, but certainly we thought it was a good idea to start with the approach where you will get these updates. And I think people have been largely receptive to this, and it's been very fun to see the software improve for people over time without them having to do anything. And so to tell Habitat that you would like to have new versions come, you need to bind this service to what is called a channel. And a channel is just a simple name. And I'll actually show you a little bit more about this on our depot. So you can see here, I can go and look up reticulum, and this is on our depot. So this is basically the internal Mozilla, come on, let's see, I don't know why it won't come up. All right, let's pick something else. Let's just do hubs. Here we go. Okay, so this is the habitat package for the hubs client that we are pushing, and you know, the question was, what is a channel, right? So when you upload a package to the depot, it starts out its life as unstable, and this is the oh, thanks MPV. I'm glad that you're liking how we did it. So this is how a package starts out. It's unstable. You know, most likely you're not running any servers connected to unstable, because it's just any uploaded package is going to just immediately deploy to your servers if you have the server connected to unstable. So you almost always have a different channel for production. And so the common pattern obviously is you promote things to stable when they are ready to be consumed by your servers. And that's actually what we do for our hubs.mozilla.com infrastructure in a lot of cases. However, for Hubs Cloud, we have a variety of different release channels. The two most common ones are Polycosm Stable and Polycosm Unstable. And Polycosm, by the way, is just the internal code name for Hubs Cloud. And so we often deploy things to unstable, and we test them internally on our internal test clusters for Hubs Cloud. You know, the arbitrary unstable packages aren't even in the place where we even care. But then when we do get to a point where we're ready to release something, we'll first promote it to unstable and do rigorous testing on our internal clusters, which would be configured to consume the unstable channel. Then we'll decide to actually finally pull the trigger. And it's when we promote that package to the Polycosm stable channel that it actually will wind its way over the internet onto your server, and Habitat would pick it up and restart the relevant service. And so that's basically what a channel is, and it's a single switch, but it has profound implications. And you know, it's quite nice to be able to utilize this in this stuff. So and so there's a variety of other things I could go into, but that's the one I really wanted to show you. And so we only have about 5 minutes left, but I would like to get to the point where I'm showing you this package install and deploy. And so so first I'm going to unload the existing one just for completeness. And you know, if you remember, this isn't a oops, I used that wrong name. And you know, this is getting packaged up into the Janus Gateway name, so I didn't really highlight that earlier, but this is not using dialog as the package name just yet for the reasons I mentioned. But just to not make it too confusing, we're going to be managing the Janus Gateway service, which in this case is going to utilize the new package we're going to install that will instantly have this Media Soup SFU. So if I go ahead and do biopackage install, and it's just in my in the place where I uploaded it, it'll go ahead and it'll go ahead and install it. It takes a little while because I think under the hood it's resolving all the dependencies, making sure everything is looking good, and then dropping the bits. And so if you look at the actual artifact here, you can see the oh, haha, I think this is because the disk is full again. Let me just remove this. This is because the disk is full on the server. So just drop that. These servers only come with 8 gigs, the one I'm messing around with, so so it is a little bit problematic. I will actually have to make a note. I do want to double check that our disks on these are not going to cause a problem with this SFU drop. Cool. Okay. So so now you can see it installed successfully. It installed 2.0. I'm making it 2.0 because it's a wholly new SFU. If anything warranted a major version upgrade, it would be this. And so this is the same little extra versioning that goes on the end there, and you can see it installed that. And you can also see that it's now sitting in my Habitat package installation folder there. And so there's my JS files. There's all the stuff I threw into the heart file. And so now we just want to see if it starts. So I'm going to do have service load, and then if I do it again, file service load. I'll do journal control F, you can see we got what looks to be a happy WebSocket server up and running. So just for the sake of doing it live, I'll get this loading here and we'll see if I actually connect, because I haven't tried that yet, and certainly we may run into problems. But as that's loading, I'm going to go ahead and just show you a little bit about what happened. So there's a HAB service folder, which is actually distinct from the packages folder. And this HAB service folder is the place where all the incidental state and all the bits that are needed to operate the service at runtime live. And so it has a bunch of stuff. One thing you'll see is it actually has the generated run hook. And so this is the run hook that, if you remember in a previous stream, I actually demonstrated this being generated, if I recall, for a different service. But in this case, you can see it's taken my template and it's actually now injected the values from the Habitat ring configuration state. Whereas I was calling it the supervisor configuration state earlier last week because I didn't want to get into the topic of distributed systems. But now what you actually would want to call it is the ring state. And so basically the ring state is landing into this run hook and then it's running. So here we go. It's the last minute of the stream, and I'm going to see if I actually got something working that I didn't know worked before we were on. So I'm going to go ahead and just pull up WebRTC here. Let's see. It's loading. Oh, because it's a big, ugly conference room. My favorite, with plants. Don't ask me why this was the only scene I imported. Maybe I'm just a masochist. Maybe it's the plants. The plants are very high poly, I think. That's why it's taking so long. But they're critical to the ambiance. Okay, come on plants, you can do it. I believe in you. Maybe we need to install Unreal Engine 5 to render these damn plants. There they are, look at those plants. They were worth the wait. Not really. I'm going to switch it just so I don't have to deal with this problem again, in case it doesn't work. Nice. Okay, so now let's see if I actually connect to WebRTC. How did I do this before? I used my webcam. Okay, let's see, unmute it. Go. Hey, look at that. I actually got something done. So it looks like the package was suitably replaced from my manually hacked together server, and it's up and running. And, you know, it was slotted in lieu of Janus. So, so that means that we're basically compatible with Janus's existing package. Now, there's some orchestration bits that still need to be built. For example, you know, actually that's a good question. I don't know why this worked now that I'm thinking of it, because ultimately, oh no, I do know. Maybe I don't even need these bits. So the thing I was going to dig into if I had the time is just service discovery. So you may have noticed sometimes that if you were to say kill the Janus server on your Hubs Cloud stack, you obviously can't get in. And part of the reason is obviously that Janus is dead, but also that the room doesn't get assigned to anything because there's no Janus servers. And so there's a whole service discovery step that occurs that ultimately will fail if the Janus server is unavailable. I forgot, we don't actually need to worry about that here, because from the supervisor's point of view, this is running Janus and it's reporting it as running Janus. The service group is called Janus Gateway, and so Reticulum is happy to think that Janus is running and therefore did assign this room to this node. I was thinking maybe perhaps there'd be some problem with that, but there isn't that problem. So really the only piece left for me to get this test out is to just go ahead, and I have to add some, no, the service discovery for room assignment hasn't changed, so that's a server-side concern, Dom. So when you create a room, or you go into a room rather, it will do a quick check and say, is the room's Janus server assigned? If it is it alive? Okay, go ahead. Otherwise, if it's either not assigned or not alive, it will go into service discovery and fish one out that's up and healthy and assign it to the room. There also might be a grace period so it doesn't stampede the ring, but ultimately that's how it works. And that is burned into the database for that room, so other people coming to the room will all go to the same place. Yes. That's a good part. Wow, Dom, you're always one step ahead of me. Even when I think you're asking questions I know the answer to, you're totally right. So this is still using the stubbed out client I was writing. And so now I think I have convinced myself that this won't be a problem, oddly enough, by it working due to the other thing I had hacked in. We won't get to see that today, but I do suspect that won't be a problem. Sometimes it takes seeing something work for the wrong reason to make you realize it will work for the right reason. But then anyhow, the only other bit that's needed before I close off on the stream that I probably will get done probably tomorrow is, if you recall, we have a completely separate client adapter for this, the dialog adapter that I authored. And so that will be something that now needs to basically fit in with the NAF Janus adapter, because we don't want to have this client code we ship be a complete switchover. We're going to need a way for the client to effectively determine, is the SFU it's talking to Media Soup or is it Janus? And if it is Janus, we should use the existing adapter. Otherwise, we should use the new one. And I haven't completely landed on what I'm going to do for that. I'm hoping there's just some very simple HTTP endpoint I can hit that will safely tell me which of the two it is. And that'll be, you know, potentially short-lived, because once we roll it out completely to everyone, we can disband the existing code path and just assume it's a Media Soup SFU if we're successful at deploying this on top of the existing Janus deploys. But in the interim period, we will need this mechanic so that the client is effectively backwards compatible with the existing infrastructure, just in case, just so we can avoid any kind of need to really rapidly push this out in a single operation. So that's what I'm going to probably do next. And once that's in place, we can actually start experimenting with this on our development cluster. And then once the SFU functionality is complete, which it may be complete as soon as today, we can try getting it live on production, but that'll probably be a little bit more time. But anyhow, a little bit over the time, but I appreciated everyone chiming in and joining. It's always fun doing this, and I'm glad it actually ended on a point where something seemed to work, even though it may have worked for the wrong reason. But the service does seem up and everything seems healthy, and so it's now using Habitat, which is cool. So anyway, thanks for joining, and I'll make sure this is archived for anyone that might be interested in visiting later, and see you next week. Hope you enjoyed it. Bye.